now we're ready to examine graphs of our trig functions, starting with the sine and the cosine functions. This is section 4.5. If we really want to learn all the nuances of the trig functions, we should examine their graphs. And because all the trig functions are periodic functions, their graphs can be easily drawn out based on once we have one cycle of the fundamental period. For sine and cosine, that's 2 pi. If we graph one cycle, we just repeat the pattern. So what I've done here is I've drawn out a chart with my angles being the top row, the x, my values for my trig function being the bottom row, and I'm going to graph, for this one, I'm going to graph y equals the sine of x. Now, to graph y equals the sine of x, oh, I'm sorry, I heard sound there and I thought maybe you'd stop recording. To graph y equals the sine of x, I plot some points, and notice here, I picked all the multiples of pi over 6 and pi over 4 between 0 and 2 pi to get a good idea of what's going on. And down below, these are the y values. Now, you know that a half is 0.5. Well, this is approximately 0.71. And this is approximately 0.87. So I can approximate my graphs here. And what I have done, and maybe you can see it here in the green, is that I have plotted all of these ordered pairs, and you see this nice little wave called the sine wave here of points. And our graph, of course, is going to be a smooth curve that contains those points. So I'm going to try to draw it with this one. Kind of bear with me. Takes a little practice. Alright, and what's going to occur now is that this is going to happen again and again and again. Now notice here, I went 2 pi this way. If I was to continue this pattern, of course it only goes out to 3 pi, but I'm going to, again, see where it stops here? I'm going to continue, and I'm going to have something that looks something about like this, which is this curve again. Well, I didn't do a very good job drawing it. And I don't think that helped at all that much. Going to the left, the pattern continues, whereas I'm going to be, I picked some of the key values here that I have memorized, and I continue my curve, my wave. And so on. And this pattern continues forever and ever and ever because the function is periodic. Due to the idea that you have coterminal angles, you're going to have a repetition of these y values. And that's the general curve there. Best I could do. Kind of sloppy right in here. But that's the general curve there for y equals the sine of x. Now over here to my right here, I have, again, notice all the ordered pairs, all the multiples of 30 and 45 or pi over 6 and pi over 4 radians. And I also have the appropriate y values because now I'm going to graph y equals the cosine of x. Now y equals the cosine of x is very much in shape like y equals the sine of x. You can kind of see part of the curve here with the points from up here that I graphed in green. And the pattern's going to continue, so let me use, let's try, see if this red pen works. And let's continue this pattern here. Let's first kind of connect the dots best that we can. Nice smooth curve. Well, it's supposed to be a smooth curve. And it's going to continue like this. Okay? From here on out, I'll do that in a different color. Maybe I should have done that on the first one, but it's going to continue. I'm trying to make it as smooth a curve as possible. Now, after you've done a few of these, you'll get much better and your curves will look much better than mine anyway. Notice here, these are the same shapes. Now I have a slightly different size here for my unit of 1 on the y, so this one might look like it's stretched out a little bit vertically, but that's the same exact shape. In fact, if you look at this graph and you look at this graph is the same as this graph, but I shifted it pi over 2 to the right. In fact, these graphs are translations, horizontal translations of each other. Now, I also wanted to point out both of these graphs have symmetry. The sine curve here is symmetric to the origin. Remember, a curve is symmetric to the origin if you can find any point or pair up any point on the curve with another point on the curve such that if you draw the line segment, the origin is the midpoint of that line segment. This is symmetric. Here, it's right over here. The sine, y equals the sine of x, is symmetric to the origin. Now remember, if a graph is symmetric to the origin, if the graph of a function is symmetric to the origin, then the function, we say, is odd. It's an odd function. Now, you can tell here that the cosine is not symmetric to the origin, but it is symmetric to the y-axis. It actually has several vertical lines of symmetry, but it is symmetric to the y-axis. So what I'm going to do here is I'm going to state that y equals the cosine of x is symmetric to the y-axis, which means that the function is even. All 6 trig functions are either even or odd functions. The cosine and the secant, I believe, are the 2 that are even, and the other 4, sine, cosecant, tangent, and cotangent, are all odd functions when we graph those. Now we're going to get to that as well. Now notice that my graph peaks up at 1 and bottoms down at -1. Peaks up at 1, bottoms out at -1, because that's the range for sine and for cosine. Peaks at 1, bottoms out at -1. There is a number that describes periodic functions that have a maximum and minimum value that kind of gives you a description of the graph, and it's called the amplitude. The amplitude kind of tells you how much the y's vary, the range varies of all the points on the curve. So when we try to find the amplitude, a lot of times they'll use a capital A, but that's what I wrote down. You take the maximum value, you subtract the minimum value, and then you divide by 2. So for both sine and cosine, the maximum value, that's the y, remember, is 1. The minimum is -1. 1 minus -1 is +2 divided by 2, which is 1. Now you say, well, why would they say that the amplitude is 1 when it looks like it should be 2? Well, you're trying to find kind of like where it is in the middle. How much above the middle, sometimes they'll call that like a midline, and how much below the middle. Okay? So that's the amplitude. Now sine and cosine are the only trig functions that have amplitude, because the other 4 trig functions, they can go to infinity and down to -infinity, so we really don't say their range is unbounded. We don't really give it an amplitude. We don't say the amplitude is infinite or anything like that, but we can here. And we can also, remember, with transformations, we can stretch our graphs. We can stretch them horizontally. That would affect the period, right? Remember, the period is 2 pi. Look at the pink here. The period is 2 pi. And then we can stretch it vertically or shrink it vertically. That would affect the amplitude. So we'll be looking at the period of functions and the amplitude of functions to get a good idea of graphs where we have trig functions that have different transformations.